Well, good afternoon, everyone. This is our panel session. Thank you for joining. All right. Over the last decade or so, large-scale spatial analysis has largely advanced and it made some significant advancements, largely due to the availability of data, new advanced processing that's available, and we can't forget additional computing power. So today's conversation will be about transforming business strategy using large-scale spatial analysis. And just to introduce myself, my name is Anthony MacKinnon. I'm the VP of Customer Success here at CARTO. And I will turn over the proverbial mic so my colleagues can introduce themselves.
Hello, everyone, again. Fawad Qureshi. I'm the Field CTO at Snowflake.
Hello, everyone. I'm Giulia Carella. I do data science at CARTO.
I'm Anthony MacKinnon. I'm with Georadix. We are a geospatial consultancy helping companies, organizations leverage their location data through maps, visualizations, and analytics.
Super. So you can see we have some experts here today. But before we start, I want to ask a question of the audience. How many of you, by show of hands, you will say that you use large-scale spatial data and analysis in your everyday jobs? Super. Keep your hands up. One more question. Of those, how many of you tie those analyses to some type of business strategy? Yes. Very nice. OK, thank you. That's a good pulse for us as we have a conversation. So let's start just with definitions. Large-scale spatial analysis. Giulia, can you help us put that into some context? What does that really mean today? We throw around these words. Let's make sure we all agree on the definition.
That's a good starting point. So it really means many different things. That's a very interesting question. So we can talk about large-scale spatial analysis if we are dealing with very large data sets. And this nowadays is very common. I mean, we've seen many examples today. Climate data, as Fawad has just showed, but telco data. Then we have near real-time data, which is a whole other word, and so on. But when it comes to large-scale spatial analysis, it's not just the large data that we're interested in. Sometimes it's a large analysis, and this means a large model. And I work in data science, so I'm very interested in that aspect. And large models are very common in spatial data science, even when you don't have a lot of data. And that's because many times we're interested in understanding the spatial correlation between the data, and we want to run a model and be able to predict everywhere. And to predict everywhere, we need to also include the location of the prediction and in the analysis of our covariance between the observations. And this means that your models are usually huge. For example, even a problem that might seem simple, like interpolating satellite swath. You don't have many data points if you take a snapshot of the satellite during a specific time. But you want to do that globally, so you need to include all these other data points for which you don't have actual information. So it's a very interesting question, and I think different people from different industries might have different answers as well. So I'm curious to know what the others think as well.
Well, I think let's also expand that, because so larger data sets, larger problems, honestly, that we're trying to tackle, it must be giving us some clear advantage. Fawad, what are you seeing in terms of new problems that we can solve today with large-scale data, large-scale analysis, that previously we were not able to solve? I know you work in the solution space every day with customers. What are you seeing?
I think when we think about the problem with geospatial data, we've got a lot of customers who generate hundreds of terabytes of geodata every single day. And in a number of times when you're working with GIS data, you are working on problems which require seasonality analysis. Okay, I am in this month of the year. What happened last month? Same month last year. Mm-hmm. So I want to go 12 months back. So I want to have enough historical analysis. I want to do month over month, Christmas over Christmas analysis. So in order for me to do that, I need to have a lot of data to be processed, and I need to have access to that raw data. Because in a number of cases, like I was discussing in my presentation, because of the way traditional GIS systems have been built, they force you to create aggregates and summaries beforehand. That early aggregation and early summarization of the data loses a lot of the value that you need to apply at a later stage. Yes, you need to do aggregation and summaries later on, but you want to have access to that large amounts of data so that I can see, okay, what was the impact on my business over the last 5 Christmases?
So we're not stripping away the inherent value of the data just to compensate for inadequacies or inefficiencies. Yep. Anthony, what do you think as well? Any new problems that you consult on that we're now able to tackle?
I think there's new problems, and also I think there's ways to solve, or better ways to solve existing problems, right? That we can do this in a much more efficient manner. We've seen today there's a lot of different tooling available, and there's more and more coming constantly. And so using cloud native formats, AI, compute engines, right, you can get answers much more quickly and accurately. For an example, many years ago, I worked with electric utilities trying to manage vegetation along their transmission power lines. And so we'd fly helicopters with LiDAR and optical cameras, and then combine all that data, analyze it, and try to figure out, okay, where you have vegetation encroachment, where you need to actually manage these problems. You get an understanding of the state of the equipment if you need to change that. Back then, it was very labor intensive, and so it takes several days. It's very costly in both time and labor. Today, you have tools that can let you do this in a matter of hours, right? And so that's why, to me, I go back to existing problems, but solved in much better ways.
These use cases never seem to surprise me, right? Managing the power lines and vegetation on the power line, those things still amaze me that we can use geospatial analysis to help us solve those problems. But maybe staying with you, Anthony, this means also that the data is coming in new formats. What are you seeing? What new formats? How is that even impacting scalability and analysis?
Yeah, I think cloud platforms are very powerful, but costs can sometimes go high and it can become hard to predict. And so it's not uncommon for these days to have both like a data lake, a data warehouse, maybe both in parallel, used for different workflows, and so you have a lot of data duplication, which is costly. There's a lot of interest that I see going to more of a hybrid approach, right? Kind of a lake house approach where you're kind of unifying your storage, and then decoupling that from the compute engine, which lets you perform much fancier analyses, but provided that you use cloud-native formats.
Yeah. Giulia or Fawad, do you want to weigh in as well on the different data formats that you're seeing? Practically, Giulia, you use it as a data scientist?
Sure. Well, we have the whole ecosystem of formats, from the old school shape files that we have mentioned a lot of times today, and then all these new formats, GeoParquet and Rasquet, that we are building at CARTO. But then it's also non-strictly spatial format that might have a spatial component that we have to dig out from the data. And this is the whole text analytics word, where location might be mentioned, but not in the form of coordinates, in the form of a bar name or a school or other things. And this is also a challenge nowadays because, LLMs have opened so many possibilities, but then is the geospatial world ready? And we've seen today that we are releasing a CARTO AI agent, but it's there is so much else more to do. I mean, it's not ending today.
Yeah. So Fawad, new formats, more data, there's a component of new skills and increased competency just in the scientists that work on this or anyone else that wants to jump in and work with this large-scale data. What do we need to skill up? How do we skill up?
I think the way the trends are coming up and new concepts are coming up, I think generative AI is a very strong tool for us to leverage in this case. And this is what we have demonstrated through our partnership with CARTO at a number of customers. That, of course, the core GIS skills are important, but what is more important is understanding the business domain. So if you understand the domain, you can interact with the system. If the system has all the collection of the data stored in the platform, you can interact with the system on natural language and it will build you those maps. Because building a map is not the big deal. Understanding the domain and applying that to close the loop and solving a business problem is the main challenge. So what we are trying to do is how do you simplify that, applying different kind of AI models onto it, different kind of techniques, and that way we can democratize access to the system. So like Javier mentioned in his slide, so 4 million GIS developers, but a few hundred million English speakers, and why remain at English when we can speak all languages?
I've heard that come up on several presentations today, understanding the customer, storytelling, not throwing all the data on the map, but making it specific for the audience, right? Domain is a big, and I see it in my job too, because we deal with so many different customers, so many different use cases. If you're not speaking the language of the domain, you fall short in the insights that you can bring, So it's not just the GIS skills and the data science skills, you have to have that specialty as well, right? Andrew, Anthony, did I say Andrew before? Anthony, I apologize. How do you, what are you seeing? So do you have to also skill up in the domain knowledge?
Yeah, I mean, I think in order to take advantage of these technologies, right, as Fawad was kind of mentioning, you have to probably organize your data. You have to train your machine learning models. You need tools to perform these spatial analytics. And you need to find ways to visualize them. So, I mean, there's more and more no-code, low-code tools which are amazing, right? They give access to so many more people to the data. I feel like you still need, to have at least the skill set internally, at least with a number of people, to perform more advanced workflows or use cases, and also provide the context, right, for these tools to work efficiently.
And we've been skirting around it, AI, ML. Let's just dive in, let's just go for it, right? It too has brought some advancements. We've seen a lot of things today and yesterday in the workshops of how it's helping us advance, talk more fluently about these insights. Giulia, tell us a little bit about main challenges with implementing AI, ML with large-scale spatial analysis.
Well, as with everything, AI has brought very good things, but also it's sometimes overused and has its challenges. I mean, if we only think about the LLM domain, we all know, and probably we have all experienced, that it's very easy to constrain, it's very difficult to constrain an LLM answer. And even if you want to use the CARTO AI agent to make the whole workflow more scalable to more people, as of today, it's still difficult to know if the answer that you get is actually a real answer or it's a made-up answer. And this is going to be a big challenge for this specific domain, because these kind of models don't really know that. I mean, I've seen that Google has now introduced a different way of grounding their LLMs, and we've talked about Snowflake, with Snowflake about that as well. But this is only just one part. And then we have the traditional spatial statistics model that have struggled in the past a lot to scale up because of all what I was discussing before. So you have these huge covariance matrices that you have to somehow solve to get the parameters, and you need a big machine to do that. But we have them now, and there are ways to actually distribute this problem, but it hasn't been done yet so far a lot. So that there is also a huge part of research, I think, that can open up to do that properly, because it's true that we can always use in spatial data science non-necessarily spatial related models that sometimes work, but if we actually have the right tools and now we have the computing power, why not go there?
Yeah. Well, one concluding question, and for me it's the big question because it connects the why. Why are we doing all of this? It's so that we can benefit businesses, we can take a leap forward with some specific insight, objective, goal for the business. Talk to me, each of you, we can take a turn. How are we connecting this with business strategy? Why is it important? Any tips for the audience? For what?
No, I think whenever I'm building a data analytics or any project, I always say that there are two words that kill any such prototype projects, and those two words are "so what." Mm-hmm. You keep asking that "so what" question yourself recursively. So what? So what? So what? So what? Until the answer becomes so obvious.
It's like the 5 whys.
Exactly. I mean, you don't need 5 whys. So what? Those two words are enough.
Yeah.
You keep asking that, and until you come to that conclusion on what really is makes sense. So this is really important for us to apply. And just to connect to on the previous question, right? So one of the big challenge that we see in the world is those silos are holding us back a lot. We talk about AI, but there is no AI strategy without a data strategy. We need to bring that data together. And then what we need to do is, in order to apply those AI skills, like this technology is prone to hallucination, how do we apply that business contextual knowledge onto it? Mm-hmm. So just as a fun little thing, last week I gave an AI detector Magna Carta, right? So Magna Carta, in case you're not aware, so this was a declaration created in 1215, taking away the rights of the kings in United Kingdom, giving it to the people. And the AI detector said 80% confidence this was written by AI. I'm not sure what was the strength of AI in medieval England. And similarly, somebody else gave the US Constitution to an AI detector. It said 98% chance it was written by an AI. So make sure when you are applying those AI skills onto it, so you apply those human judgment and contextual knowledge, and don't just trust that AI model blindly.
Yeah. Any final thoughts on the business?
To me, these technologies have the potential to unlock tremendous value. And so I think it enables you, right, to get to react to in near time or real time or near real time, right, to changes that impact your business. I mean, if you're migrating away from more traditional infrastructure, I mean, it's not trivial, right? So you have to plan that carefully, but I think there's an important cost as well if you don't do that transition, because others will, and you might be left behind.
That's true. Giulia?
Well, to add to that, I would say that having an in-house expertise, not to promote the category, but of data scientists that can understand both the business side and also the technical side, I find it always very helpful when I talk to clients, because then whatever you build, it doesn't just float up there. I mean, it's then leveraged more and pushed more. So you need someone inside as well to be able to do that. You just can't rely on things that are built as a one-off.
Mm-hmm. Yeah, so we have the opportunity to take large leaps forward, but we're not there yet, right? And I think the message too is always ask, so what? I like that. I think that's the takeaway. Always ask, so what? Get that domain knowledge to impact and influence the bottom line. Why are we doing this? What business objectives does it benefit? And really make a story. I love everything that has been said yesterday and today about storytelling. I think that should be our job number 2, right? It's a data analysis, getting insights, but then storytelling to really democratize all of the work that we've done. Well, thank you so much. You've been a fantastic panel. Loved having the conversation, and thank you, audience.